So we're going to do some extensive radicals. Okay, so the amount we're going to cover today is actually more than we actually need in grade 10. But while we're covering it, we like to cover it in depth. Okay, and so that we can we can really use it in the simpler cases in grade 10. So let's go back to the basics. What does this mean? Why is this equal to 2? So let's first define it. Let's recall what it means, right? So if you have square root of x is equal to, let's say, a, right? That means by definition that x is equal to a squared. Okay? Now this actually means a few things. Right away, what that means is that x has to be positive. Because anything square on the right side, anything square, can it be negative? Is it possible for this to be negative value?
No.
This always has to be positive, right? So that's why we can never put anything a negative value in the square root. So for example, if you have a square root of negative 1 and you say, so let's say that's equal to a, it's impossible for a squared to equal to -1. Of course, when a little bit down the road, we're going to talk about that as an imaginary number, and we're going to do talk about it as a separate topic. But in terms of real numbers, we can't come up with a number when you square it, it becomes a negative value. It's always positive, right? Okay, so the first basic properties, right? So it's radical square root properties. Okay, so we want to formalize it, understand some rules clearly so we can do them faster. Okay, the first ones are, if you have a square root of a squared, right, that's equal to square root a squared, and that's actually equal to a. That's the first property. So let's discuss how we can show that this and this is equal to each other, okay? So squaring first and then square rooting, and square rooting something and squaring afterwards. Okay, so let's say this is equal to, let's call it b. Okay, let's say that right there, square root of a square is equal to b. Okay, or sorry, I'm sorry, I mean c, like something different. And we're going to show that b and c are actually the same thing. Okay, so by definition, we have to use this definition. This is the definition of square roots. Okay, right there. So you should write that down too. This is the definition. Okay. I know you guys kind of know it in your mind, but it's always best to write down the exact definition. Here. Using the definition, okay, I can say that right there, inside the square root, right? So a squared, by definition, is equal to b squared. Okay. Which means actually, in this case, a is equal to b. Here, so I have something squared is equal to c. Okay, I have something squared is equal to c. Note that I don't want to use this property yet. So to show that b and c are same, I can't use the fact that this is actually equal to a. So I can't just translate that into a yet. Okay. So what I can do though is, doesn't that mean that this is equal to c? So if you have anything squared, it's equal to 4. How do you isolate x? That actually means, so we're actually going this way. We're actually going this way. So this right here means this, right? So that right there, so what I'm saying is this right there is this one, and this right there is this one. So I can say, look, see this x? The one without the c gets a root c, right? The one with the square, it disappears, right? So I follow the definition again. That's the exact same operation on the number a and c. They're equal to each other, which means a has to equal to c. Now, typically though, here you actually have to put plus minus 2. It's not correct to say x is equal to 2. Okay, the reason why I can just say it's plus root of c is because we know that a from here a under a root, x is always positive. So if you have something positive squared, can it turn into negative value? Can it turn into negative value like plus? Can it be a negative value? No. That's why we can just omit the negative. Usually we do it. You have to do it. But here we omit it. So look, I have a is equal to b and a is equal to c. What does that mean?
A, B, C are all equal.
Yeah, so b and c are equal to each other. So these two must be same. I don't know, that's a lot of algebra there, so it might be a little bit confusing, but I've just shown that these two are same using the definition. Of course, they're both equal to a. Okay, so here's the first example. According to the first property, if you have a square root of 3 squared, what do you get? Square root of a, you get just a.
Oh,
So it's going to be 3, and this is the same as square root of 9 squared, right? So you're going to get 3 minus 9. So minus 6. So how do I use this property here? How do I use... I want to use this, square root of a squared or root of a squared. I don't have square here. I have a 4 here, right? But using the property of exponents, I can write it like this. Can I not? That's how you write it. That's how you convey that you know exactly what you're doing. Okay, this is 4 squared. Now just this part is going to equal to, by the first property, it's going to equal to 2. And that right there is going to equal to 4. So we get a 4 minus 4, so it's equal to 0.